I'm going to explain how to make a polygon shape using Affinity Photo's Procedural Texture Filter. I've done the polygon shape before, but I didn't really understand the math behind it, and I've been studying the math and I think I understand it pretty well now. So I'm going to go through the math and how to make the polygon shape. One of the reasons I wanted to show the polygon shape again is that I've come up with a bunch of new patterns and textures, and I want to show those, but they're all based on the polygon. So I'm going to show the polygon shape first, and then I'll have some other videos that show how to do some of these other patterns. I originally came across the formula for the polygon shape in the Book of Shaders. I'll put a link to the Book of Shaders in the description for the video, although I'm not sure if it's still available. It seems like last time I tried to access it, I had a problem. To get started, I'm going to think about a set of axes and then a radial arc that goes from 0 degrees up to 45 degrees. The arc just follows a circular path. What I want to do is, as I increase the angle, I want to stretch out the radius until it forms a straight line. And the formula that does that is to divide the radius by the cosine of the angle theta. The cosine of theta is symmetric about the x-axis. So if I look at theta going from minus 45 degrees up to plus 45 degrees, and I take r divided by the cosine of theta, then I'll get a nice straight line going up here. Now, this will be useful in creating a square, which is where the number of sides of the polygon is equal to 4. When we go to make the second side of the square, you can see that just dividing by the cosine of theta doesn't work. So, for instance, cosine of 45 degrees is square root of 2 over 2, which is okay. But then the cosine of 90 degrees is 0, and the cosine of 135 degrees, which is the far side over here, is minus square root of 2 over 2. So that is not going to work. To fix this, I'm going to create a new variable. I'm going to call it theta prime. And what I want it to be is, for the first side of the shape, I just want it to have the same values as theta. But for the second side, I want it to be restricted to somewhere between minus 90 degrees and plus 90 degrees, always in that range. And so it'll have the same values as the first side of the shape. In the example of the square, the second side, the angle goes from plus 45 degrees to plus 135 degrees. I'm going to have theta prime go from minus 45 degrees to plus 45 degrees. All I have to do is subtract off 90 degrees. For the third side of the square, I have to subtract 180 degrees from theta, and then for the fourth side of the square, I subtract off 270 degrees from theta. Now I want to do this all in one function, so I'm going to use the floor function to create this theta prime variable. The first step is to figure out how much angle is swept by each side of the polygon. So for the square, n equals 4, and it sweeps out an angle of 90 degrees. So I'll create a variable s, which equals 360 degrees divided by n, and in the case of the square, that'll be 90 degrees. Next, I want a floor function that goes from 0 when you're on the first side, and then 1 when you're on the second side, 2 when you're on the third side, and 3 on the fourth side. And I'm going to multiply that by my s value. So I'll have 0, 90, 180, and 270 degrees. Now theta is going from minus 45 degrees to plus 45 degrees in the first side here. And so if I divide by 90 degrees, it'll go from minus 1/2 to plus 1/2. So I need to add a 1/2 to that to get it in the range from 0 to 1. and then the floor of that will just be 0, and so that'll take care of it. The final formula for theta prime is theta minus s times the floor of theta divided by s plus 1/2. And this will work for all the sides of the polygon. Now I'll show how this is implemented using the procedural texture filter. I'll start by creating a new document. Set it to 1024 by 1024 pixels. Make sure it's an RGB mode. Create that. Fill it with black. And choose a new live procedural texture filter. I'll add a single equation, assign it to all 3 channels. I'll add a single real number input A. I'll call that scale. Set that to 4. Then I'll add a integer number input for the number of sides. That will be n. And to get started, I'll set this to 4 as well. I'll start with the variable s, which is equal to 360 degrees divided by n. And then I'll do a coordinate system. Variable v equals vec2. And I'll use relative x and relative y so that I can drag it with my mouse and move it around. And multiply by a, which is the scaling factor, divide by w, which is the width of the document in pixels. So there's my coordinate system with the red and the green channels. Then I'm going to get the angle theta from that, so I'll use variable th equals, I'm going to use the atan2 function to return the a tangent value, and that typically takes y and x as the 2 values. So I'll use v dot y from my coordinate system and v dot x for the 2 values for the a tangent function. And then I'm going to set up my transform theta prime variable, which will be vartp, I'll call that. And that will be theta minus s times the floor of theta divided by s plus 0.5. And then finally, I will take the length, which is the same as the radius, length of v, times the cosine of my transformed theta, tp. And you can see that I have sort of a square shadow image here. If I change the sides, 3, 4, 5, 6, 7, okay, gives me any number of sides. Now the other thing I could do, if I add a 0 to 1 range input and make this, label this E, and call this the edge, I can put a step function around this and put an E in there, and I can create a different shapes. Now I'd sort of like to have the top pointing, instead of going over here, I'd like it pointing straight up, and I can do that by adding an angle input. I'll label that ph for phi, and I'll call this one angle, and then I'll just add that to my theta value. And then if I rotate this down at 270 degrees, the point of the pentagon will be pointing straight up. And I sort of like that a little better than off to the side. But you could rotate this for other values too if you want it rotated in a different way. The other thing I could do is to, instead of a step function, I could replace this with an oscillator function like that. And then if I zoom out a little bit, I get something like that, and then I could just add an adjustment to this and go to a gradient map and just choose one of the gradient maps, maybe like that. And there I have sort of a nice little pattern just looking at it that way. So that is the basic polygon shape. Please leave a comment if you come up with any cool textures based on this or any of my other patterns that I've shown. And let me know if you have any other comments or questions. And thanks for watching.